So in this video I want to talk about how to calculate a certain class of trigonometric integrals, and these are integrals where they have the following form. They either involve a sine multiplied by a cosine, or a sine multiplied by a sine, or a cosine multiplied by a cosine. The arguments of these trigonometric functions are always linear in x, so it's just x here and x here, where I'm assuming that x is the variable we're integrating over, and the constants in front of this variable x, such as here a and here b, are generally different. So this could be, say, 2, and this might be 7, or other possible constants. So that's what we're going to be looking at, and the reason why these integrals come together in one class is because they are all solved using the same technique, and they're all based upon knowing a couple of trigonometric relationships. So what I'm going to do now is pause, make a little bit of room, and look at these relations from which we're able to calculate this class of integrals. So the equations that we need to know are based upon the following formulae. We need to know the cosine of a plus b. From that, we need to be able to write out what the cosine of a minus b is, and similarly we need to know the sine of a plus b, and from that we need to know the sine of a minus b. So these are extremely important things for knowing the equations, and what I would like you to do now is to complete these, to work out what these are equal to. Hopefully these are things that you know off by heart. If not, I would very much recommend that you do learn them, and based upon that we will be able to continue the video and calculate these integrals. So perhaps you should now just work out what these are, write them down, and pause the video while you do it. So, welcome back. So the results that we have are the cosine of a plus b is the cosine of a multiplied by the cosine of b minus the sine of a multiplied by the sine of b. The other relation that I know off by heart is the sine of a plus b is the sine of a multiplied by the cosine of b plus the cosine of a multiplied by the sine of b. These are the two key formulae, and the others can be written down with a moment's thought from the symmetry properties of the sine and cosine functions. And in particular, we're relying upon the fact that the cosine is an even function and the sine is an odd function. So let's look at the cosine of a minus b. We can think of this as being the cosine of a plus and then minus b in brackets. So here you would have the cosine of a multiplied by the cosine of minus b. But the cosine of minus b is the cosine of b because the cosine is an even function. So we can write down immediately here the cosine of a multiplied by the cosine of b. And then we have minus the sine of a, and then here we want to write the sine of, and then in here I would write minus b, but the sine of minus b is minus the sine of b, so I can bring a minus sign out, which makes this positive, so I put a plus sign here, and here this becomes b. So in a similar way we can complete this relation here, that this is the sine of a multiplied by the cosine of b minus the cosine of a times the sine of b. So these are our four key equations, and what I want to do on the next slide is to show how from these equations we can rewrite, for example, this integrand here, and also how we can rewrite one of these two integrands. And I'll leave the other one of these two for you as an exercise. So let's pause and go on to the next slide. So all I've done so far is I've written out our 4 key formulae from the last slide, and I've written out an integral of the form that we want to calculate. So here it is, the sine of little a times x multiplied by the cosine of little b times x, all integrated with respect to x. So in our integrand we have a sine multiplied by a cosine. If we look at these 4 equations here, sines times cosines only occur in the first 2. They occur here and here, here and here. In the second pair of equations, equations 3 and 4, we only have cosines multiplied by cosines or sines multiplied by sines. So these equations in grey are not going to be useful for rewriting this integrand, whereas the equations 1 and 2 are useful for it. So in particular, what we realize is that if we add equations 1 and 2 together, we're going to obtain the following. So let's look at it. If we add 1 and 2, we will get this plus this is going to be, now these terms are the same, so we will get 2 times the sine of A times the cosine of B. But these terms are going to cancel because of the different sign in front. So adding 1 and 2 together will give us twice sine A cos B is equal to the sine of A plus B times plus the sine of A minus B. So we're going to get that 2 sine capital A cos capital B is equal to the sine of A plus B plus the sine of A minus B. So that means that the sine of A multiplied by the cosine of B is a half brackets sine A plus B plus the sine of A minus B, close big brackets. So all I've done in the last step is I've divided both sides by a factor of 2. So what we see is that from this first pair of equations we're able to write a sine multiplied by a cosine, it doesn't really matter what the arguments are here, as a half times the sine of the sum of these arguments plus the sine of the difference of the arguments. So let's now look at this equation here. So what we're going to find is that our integral is going to be, now there is a factor of a half here that's going to be multiplying everything here, so we might as well pull it outside the integral sign immediately. So we have a half times the integral, and then it's going to be the sine of the sum of these two arguments, just as here we just add the arguments together. So it's going to be a times x plus b times x, where these are little a and little b, and because x is a common factor I can actually immediately write that as brackets a plus b close brackets times x. So that's our first term here. The second term that we're adding to it is the sine of, and now it's going to be the difference. So it's the argument of the sine here, little ax, minus the argument of the cosine, little bx. So in the same way that's going to be brackets a minus b close brackets times x close brackets, all integrated with respect to x. So what we realize now is that we've gone from this difficult looking integral to the sum of two integrals, the integral of this and the integral of this, and these are both straightforward integrals, in the same way that if you're happy to integrate the sine of 2x, you should be happy to integrate the sine of a plus bx, where a plus b is just a constant multiplying x. So what we're going to get is that I is a half, and now we can open big brackets, and the integral of sine is going to be minus, and there is going to be a cosine, and it's going to be the cosine of a plus b, close brackets, x. Now if I differentiate this, I'm going to get a minus sign when I differentiate cosine. That will make this into a plus sign, which is good, but I'm also going to pull out a factor of a plus b from the chain rule. I don't want that factor of a plus b because it's not there. So here I have 1 over a plus b. And in exactly the same way, from the second term, I'm going to get minus 1 over a minus b times the cosine of a minus b, all in brackets, times x, close brackets, and I close the big brackets because this factor of a half is multiplying everything here. And what I can do now is recognize that I have a common factor of a minus sign here and here, so I can just as well make this positive, and take the minus sign factor outside, and that is our final expression. And that expression is one that you can verify by differentiation. You can differentiate this, you're going to get back to signs. You can rewrite the signs using equations 1 and 2, and what you will find is that everything will cancel and you will return to your original integrand. So I will leave that for you as an exercise. Exercise, differentiate to check. Essentially all you'll be doing is just going backwards. As I say, you differentiate, you'll obtain these equations, and then you go back here and here using these equations that we've called 1 and 2. So that's how we can integrate a sine multiplied by a cosine using the first two equations, and it's perhaps not surprising, and when we're going to think about it in a moment we'll see that to calculate the integral of a cosine times a cosine and the integral of a sine times a sine, we use these other equations here. So on the next slide I'm going to write out these two equations and use them to calculate an integral somewhat of this form, but involving a sine times a sine or a cosine times a cosine. So we'll do that on the next slide. So what I want to do now is to consider the following integral, which involves a cosine multiplied by a cosine. The arguments are both linear in the variable that we're integrating over, and they have different numbers in front of them. So as we've just intimated, the relevant equations that we're going to need are those for the cosine of a plus b, written here, and the one that follows from it by the symmetry of the cosine and sine functions for the cosine of a minus b. These are the equations I called 3 and 4 on the previous slide. The reason that they're helpful is because they both involve cosine times a cosine. However, they also involve a sine times a sine. For this integral, I don't want these terms, I want to get rid of them. So the natural thing to do is to add 3 and 4, and then they will cancel. If I was looking at an integral which involved a sine times a sine, then these equations would again be useful, but I wouldn't want the cosine times the cosine. I want to cancel these, so I would subtract 3 and 4. I'll leave that for you as an exercise. So let's look at this integral and realize that what we need to do is we now add 3 and 4. And what that's going to give us is that 2 times the cosine of A times the cosine of B is the cosine of A plus B plus the the cosine of A minus B. As I said, the signs will cancel. So we want here cosine times a cosine, so we can divide here both sides by 2. So therefore the cosine of capital A times the cosine of capital B is, and I'll just put it as a half times big brackets, times the cosine of A plus B plus the cosine of A minus B, close brackets. So we identify now what capital A and capital B are going to be. So we identify capital A is going to be 2x and capital B is going to be 7x. Now actually, in this case, because these are both cosines, whichever one you choose for A and whichever one you choose for B makes no difference whatsoever. And because there is an A minus B, it might well be better to choose A being 7x and B being 2x, because that way we would have the cosine of 7 minus 2, which is 5x. But I've done this here deliberately for reasons which I hope will become clear in a moment. So let's look at our integral. What we have is that the integral of the cosine of 2x times the cosine of 7x with respect to x is going to be, now again there is a half in front of everything here, so since that's going to multiply everything inside the integral, we might as well just take it outside. It makes the integral look simpler and less threatening. And then we have inside for our integrand now the cosine of, and in our first term we have A plus B, so that's 2x plus 7x, so that's 9x. And we then have plus the cosine of, and now it is going to be A minus B, so that's 2x minus 7x, so that is minus 5x. And this is all integrated with respect to x. So, before we actually perform the integrals, I'd like to point something out. I don't think, if we're integrating things like the cosine of minus 5x or the sine of minus 5x, should we have that, that it's very helpful to perform the integral immediately. Instead, what we should do is we should realize from the symmetry properties that the cosine of minus 5x, because cosine is an even function, is the cosine of plus 5x. So let's just recall that the cosine of minus 5x is actually equal to the cosine of 5x. And this is because the cosine is an even function. For the sine function, the sine of minus 5x is minus the sine of 5x, and that's because the sine is an odd function. I think it's worth making these substitutions before we perform the integral, because that's going to give us fewer minus signs to worry about. So let's make now this immediate change here in our integral in the line above. So in other words, all I'm going to do is I'm going to make this positive, and I leave this sign outside because of the even property of the cosine. So having done that, we can now perform the integral. So we find that the integral of the cosine of 2x times the cosine of 7x with respect to x is a half, open big brackets, the half is after all going to multiply both of these terms. Now the integral of cosine is sine, so we are going to get 1/9 times the sine of 9x. Let's just check that immediately. When we differentiate sine, we're going to get cosine, and when we're using the chain rule, multiply by the derivative of the argument, the derivative of 9x will pull out a factor of 9, which will cancel the 9th, and that will give us this. So this is correct. We then add to this the integral of the second term in exactly the same way. That's plus 1/5 times the sine of 5x. Close big brackets, and if you wish, let's add an integration constant. So this is our result for this integral, and what I'm going to do is to encourage you to check by differentiation that this is correct, that we've not made any mistakes. So when you check by differentiating you're going to get this, and then in both cases you're going to say, well, 9x is 2x plus 7x, and use this formula, and you want to say that 5x is, say, 7x minus 2x, and work backwards and use these equations, and you will get back to your original integrand, and you may have to use the symmetry property, the even nature of the cosine as well. So with that, I will stop this video.